Okay, I am here. Let's see here. Let's go with hellos. Hello. Alright. Good. That works. Alright. Let's hopefully we get a few more people to come in today. Alright. Okay. How's it going, everybody, today? I hope everybody's doing well today. Woo! I've made some adjustments to the stream, so hopefully it's going to be a lot better. So hopefully the quality is going to be a lot better, and you'll be able to follow along a lot easier without all the starts and stops. So wait for a few more people to come on in. All right. Okay. Let's see. All right. Hi, Jonathan. Yes, I got your email. Yeah, I've been getting several emails there, Jonathan, regarding I guess a quiz of some sort. I don't think I ever put up a quiz, so you don't have to turn anything in. So I guess I'll just make that clear. There's no quiz to turn in. So I don't know where you saw the quiz part there. That's what I'm kind of getting confused about. Did I put something in there regarding a quiz, or what? What was the maybe? Because I borrowed a template, so maybe I accidentally left some information in there. What's the story on that? Because I mean, I don't know what the quiz stuff is. That's what it's kind of confusing even for me. Can you guys hear me okay? Am I coming through okay? Okay. Yeah, I don't have quizzes in the class, so all right. like I said, I've made a lot of tweaks. Oh, okay. All right. You know what? I think that's probably from the schedule. All right. All right. Yeah, you know what? That's probably from the schedule. I need to modify that because I could have sworn I had actually erased those that schedule stuff. Okay. You know what? I'll make that adjustment, and then yeah, you won't have a quiz to turn in. So yeah, I can see why the confusion is there. Good morning. How's it going? Good morning. I'm gonna get started just a bit late here because just a few people starting to trickle in. That makes sense though. We'll go a little over time as well. So like I said, I made a few adjustments to the stream here. I'm hoping, I was just working on the back end a little bit this weekend, just trying to get things to work out. I think I've made I made a couple of changes there that I think will be better off. If you notice here, the source is at 1080p, so I'll probably look a lot sharper than I did before. Not that I look great to begin with, but it is what it is. And so hopefully things will be easier to read and the stream won't fall off. I think we should be okay. So it won't stop and stall. Hopefully, like it has been the past couple weeks there. So if you're having any issues on your end, let me know. If your stream stalls for whatever reason, then hit F5 to refresh, and then restart the stream if it decides to stall out or buffer or whatever. Okay, so yeah, that's my best hope for today is that everybody will be okay, and we'll go ahead and get started. So actually, we'll go and get started right now. All right. Okay, let's go ahead and get started here for today. Welcome back to Tuesday. Hopefully, everybody had a very nice and wonderful Labor Day weekend. All right. So we're back here today for the first of two classes here. Yeah, Jonathan, the assignments are not due until the first exam. So, yeah, you're not even late. You're perfectly fine. They're not due until the day of the test when I announce when that test is. So, once we're done with chapter 1, then that's when I'll announce the first test. So, you're actually on time. No problem. Yeah, I don't make it due like every week, just the day of the test. Just a lot easier for you to take your pace, okay? Ooh. All right. It's really dry out there today. Anyway, okay. So today we're going to go over the rest of section 1.5. We're going to talk about a few things here that are here in the notes here from the handout, and then we're going to move on here to talk about a few more things in section 1.6, which is long division, and then we'll do section 1.7 as well, which shouldn't take us that much time to do. And so we're gonna put these things together here now. One of the things that we'll need here today is we're going to go ahead and need a calculator. So if you have a calculator next to you or something like that, make sure you take that out there. That'll be a little bit helpful for today. So we're going to use it in a small capacity, but one that could be helpful nonetheless. All right. Okay, so let's go ahead and start here. So last time we did some, regular short division / long division. We saw a way how to do that. That wasn't so hard. Now, that wasn't so bad, I guess you'd say. I wouldn't say it's so hard. In any case, what I want to look at here today is the other half of doing division, which is talking about seeing what numbers are divisible. So for example here, if we say divisibility, what does divisibility mean? Let's take a look at that. So this is on page 40 on your notes there. So please make sure you're on page 40 of your notes. All right. So what does a divisible number mean? Meaning to say it divides it evenly. So meaning to say, okay, if we divide it out, we get a remainder of 0 here at the end of the day. All right. Nothing crazy going on here. There it is. Good stuff. Now, there are tests for divisibility. So, for example, here, numbers that 2 divides, or numbers that 3 divide, or numbers that 5 divide, or numbers that, 6 or 7 or 8 or 9, or they all divide. So, there's some tips and tricks here to know what numbers are divisible. So, meaning to say, if it's divisible by 2, if you can divide by 2, then every number, if the last digit is 0, 2, 4, 6, or 8, then you can divide that by 2 without too much trouble. If the last 2 digits make a number that's divisible by 4, so for example, if you take those last 2 digits and you add them together, if you take those last 2 digits, and you just divide it by 4, if you can divide that by 4 evenly, like 16, then that's okay. For 5, if it ends in 0 or 5, so pretty simple. I don't think people have an issue with that, like 15 and 10, so no problems there. 6, if it's divisible by both 2 or 3. 7, no simple test. 8, if the last 3 digits make that divisible by 8. 9, if the sum of the digits is divisible by 9. And 10, if it ends in 0. Now, the one I skipped here is 3, specifically, is that the sum of the digits is divisible by 3. So you actually have to take, I'm going to go ahead and put up a small example here. So, the example here specifically is, let's say I took an example here and I did just 123. And I said, okay, do I know that this is divisible by 3 or not? Well, all you have to do is take the sum of the digits. So we're going to take 1 plus 2 plus 3, and then that, if we add those together, 1 plus 2 plus 3 equals 6. And 6 is divisible by 3. Because 6 divided by 3, again, 6 divided by 3 is equal to 2, remainder 0, right? So when it says it's divisible, we have a 0 remainder there, and so then that's perfectly fine. You're in the first class, but you're well into you're in the first class there, Carissa, but you can certainly I'll be teaching the same lecture regardless, so no problem. This is Math 90. That's fine. You can stick around. You don't have to be like, you could, like, if you're in 11 o'clock class, you can come here at 9:30, so that's perfectly fine. If you want to come in at the 11 o'clock class, that's totally up to you. Okay, nothing to be sorry about. It's all good. I give everybody the option. It's so that's for the, no need to be sorry though. Okay, let's go over some examples here on this page. All right, really quick. So let's look at 258. Let's just simple yes or no questions. Okay. Is 258 divisible by 2? So just type in the chat there yes or no. Is 258 divisible by 2? Okay. Yes, yes, okay. Very good. All right. So the answer is yes. All right. Again, perfect. It ends in 8, right? So it's definitely divisible by 2 because it ends in an even number. All right. How about let's do the next one here. How about 307? Is 307 divisible by 2? Yes or no? Alright, no. Alright. Good. The answer definitely is no. Okay, the last number there is 7, and 7 is not an even number, so we cannot divide that straight up by 2. Perfect. Let's take a look here at a couple numbers, see if it's divisible by 3. Okay, so divisible by 3. Alright, so they have a couple examples here. Again, if it is divisible or not divisible. So here's divisible, here's not divisible. Again, you're going to add up the digits here and then see if that sum is divisible by 3. So let's take letter C here. 374,214. So split up all the digits, add them together, and yes or no, is this number here divisible by 3? Okay. Alright, Maricela says yes. Yes. Okay, so a couple people say yes. Alright. Let's see if we get a few more answers here. Yes, alright. Alright, so the answer to this question here is indeed yes. Alright, that's right. So, again, just to show this off here one more time, if we're looking at that specific number, alright, so let's go ahead and just take a look. We have 374,214. So that's 3 plus 7 plus 4 plus 2 plus 1 plus 4. And if you add those together, the answer is 21. Maricela, I see the cat has stepped on your laptop there, or keyboard. Oh, you dropped it? Oh no. I hope it's okay. Alright, so this is indeed equal to 21, and 21 indeed, if you divide that by 3, is indeed equal to 7, remainder 0. Okay, so yes, it is divisible by 3. Alright, let's keep moving on here. Alright, so divisible by 5, pretty simple. Divisible by 10, again it ends in 0, then it's divisible by 10. Okay, so this test talks about divisibility. There's just a few questions in regards to that. I'm not going over this too much because, again, some of these are pretty straightforward, like 5s. If it ends in 5 and 0, wow, okay, no big deal. Alright, so we'll talk about, you'll see where this is more applicable as opposed to just kind of showing what it's divisible by necessarily. So we'll take a look at that. In other concepts. All right. In any case, we're going to skip section 9.3. Again, we're not doing chapter 9 here, and we're going to go straight to page 44. And we're going to be doing some long division. Okay, so some long division here. All right. Okay, so we're going to talk about how to do long division and how it's, how we're going to kind of structure things around doing long division, and we'll see exactly how things work out. Okay, so here we have 3066 divided by 42. Now, admittingly, 42 is a very large number, and a lot of things to talk about, certainly. But let's go ahead and see how we can figure out this particular problem. Now, remainders are certainly possible here. Okay, that's not outside the realm of possibility. But we're going to go ahead and do this division problem here. Alright, and then we'll talk about also the steps here behind this process. So I'll kind of show you how you would want to do the handwork here, and how you can kind of check that through So we'll see exactly how that works out. Okay. All right. So let's talk about the steps in doing long division. Okay. Long division here. All right. Okay, so if you have your calculator out, I want you to plug this into your calculator. So let's try this here. So again, step one here, if we're gonna do, I mean, there's a couple ways you could do long division, but we're gonna kind of do it because of how fast we're gonna go over this section here. We're gonna kind of do it the cheap and easy way. Step one here is just to use the calculator and find out how many times the divisor goes into the dividend. Okay, so meaning to say, on your calculator here, can you do 3066 divided by 42? Anybody tell me what we got there? Alright, so we got 73. Okay. So the second step is to find it if necessary. So we got 73 here, so we're going to put 73 up top here. So this is what we get, 73. And so if you're going to show me the work here really quick, alright, so if we're going to put 73 here, I'm just going to take this 7, I'll multiply this by 42. So let's do that next. What's 7 times 42? What do we get there? We had 7 times 42. 294. Okay. So we get 294 for that. Now we want to just do regular division, right? So if we want to find a remainder, this is how you're just going to essentially show the work. If you're not sure, 7 times 42, again, push that on the calculator or write that out, which way you want to do. Again, we want to kind of do these a little bit quicker and faster here, so that's why I'm kind of taking a kind of a shortcut method here. So what do we get here? 306 minus 294. What's that going to be? .306 minus 294. Well, I agree this is 2. I believe this is 1, so just 12 there. 2772. Oh, okay. Wait. I'm a little confused now. What? Alright, I'm a little confused about that. Anyway, so we get 126 here. Then you do 3 times 42, which is 126. So as you can see here, this is a remainder of 0. Okay. So you're just gonna, if you're gonna show me the work here, this is the way I would like you to kind of do it. Alright, so again, it's a nice little kind of short, shortish type of method there. You can go ahead and just, get that through without too much trouble. Are there any questions about that, by the way? I want to be sure that you kind of see, like, we're trying to want to do these a little bit faster. So, any questions? Again, type out a question or type no in the chat so I can move on to the next example. That's fine. All right. So let's go ahead and do another example here. So I'll just make up some numbers now. Well, actually, no, I take that back. You guys have notes there. So let's go ahead and look at the next one here. Let's go ahead and do this one here. Actually, no, not that one. We'll do, sure. We'll do this next one here. We'll do letter C. 8784 divided by 61. Alright, so we'll do that next one here. 61 here. This is on page 45 of your notes. Okay, so let's go through this carefully here. Alright, so again, go ahead and put 8784 divided by 61. And can anybody tell me how many times does 61 go into 8784? $144. Okay. So, all right. So basically, what we're going to do, 110. 110. Not quite there. Yeah, 144 would be correct here. Again, on the calculator, just do 8784. Okay, and then divide that by 61. So you may get 144 dot something something, but in this case it's 144. Now, to show me the work behind that, what I would like you to do here is to show me the work behind that, what I'd like you to do here is, again, we're just going to go one step at a time here. So we're going to do 1 times 61, which is 61. So essentially what you're doing here is just showing me the work behind this process here. Do 87 minus 61, that's 26. We'll bring down the 8. Alright, it goes 4 times. And if you do 4 times 61, that's going to be 244. So that's going to be 224. If we subtract, bring down that last 4, and then that's where we get 4 times 61 again. So it gets another 244. Alright, so I'm just kind of showing off here how we can get through these rather quickly so we don't have to. It does take quite a bit of time if you're kind of doing the mental math behind it, because it does tend to be tedious if you get to have very large numbers. So yeah, it's just one of those processes that can be, excuse me, very, very tedious if you're not careful. All right, let me check that really quick. Let's see if I want to modify that problem. Probably. Okay, that's perfect. Okay, let's do this next one here. All right, so again, not every long division problem is going to necessarily not have a remainder. Let's take a look at where we can have a remainder. So let's look at this one here. We're going to do 6649 divided by 89. Okay, so let's look at that next one there. Okay. So let's put the okay. Okay, so once again on the calculator there, tell me how many times does 6649, does 89 go into 6649? So let's do that division there, and can anybody tell me what they got there? In this case, you will get some kind of random decimal number, but we only care about the front part. So don't worry about the decimal part. I only care about the front part, the actual whole number. Okay, great. 74 is correct. All right, nice. All right. So like I said, this is kind of like a fast method here. So, all right, so we get 74 there. Now we're going to go ahead and proceed with the rest of the work because you saw you got 74 point blah, 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 blah. Now, we're not dealing with the point blah, 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 blah stuff, but we are dealing with remainders here in this chapter. So we do need to show off the work here and see what our remainder is at the end of the day. So we're going to take this 7. All right, so showing me the work here, we're going to take that 7, multiply it by 89. What do we get there? 7 times 89 is what? $623. Okay. Again, you can type that out if you like. So there we go. Now we get 664 minus 623. All right, so that's going to be 1 and 4, so it's going to be 41. And we'll bring down the 9. All right. So far, so good, everybody. Looking good. Okay. Now we have 4 times 89 because we have this 74 up here. So 4 times 89. So what's 4 times 89 here? Times 89. Okay, 356. All right. All right. So 356 is correct. Okay. So let's subtract these two. We have 419 minus 356. All right, what's that going to be? $63. Okay, good. That's right. So here we have our answer. Our answer is going to be 74, remainder 63. Okay, and that'll be our final result for this problem. Hi Vulcan. Yeah, I can do Calculus 1. I go up to Calculus 1, so I'm pretty decent at calculus. Because Calculus 2 or 3, I haven't done it in such a long time that I don't think I'll be much of help, unfortunately. Oh, I can help out with derivatives. That's not a problem. Vulcan, if you want to come back at like at 12:30, when I'm done with these 2 classes, then I can certainly help you out with derivatives. That's not a problem. Okay, it's 12:30 Central Time, so apologies about that. That'd be like 2.5 hours from your time. So I don't know which time zone you're in, but think 2.5 hours from your time. All right. Are there any questions about this example here? 6649 divided by 89. Okay. All right, now I'm going to have you guys try. All right. So once you guys give this a try here, all right, 4791 divided by 23, okay? So let's use the previous two examples there, 4791 divided by 23. And I'll give you like a couple minutes or so to work that out, okay? So this is our next example here. I'm not going to write it out just yet, but let me give you guys a couple minutes. Go ahead and, you know, kind of see if you can write that out on a sheet of paper, whatever. Okay, and tell me what you get for your answer there in the chat. Give a little bit of time. So. Yep, put that in the chat there, so you know what we're doing. Go ahead and put that up here. Give another minute there. Okay. Alright, so let's go ahead and take a look at this one here. Does anybody have an answer for me? 4791 divided by 23. Does anybody have an answer for me for this? $208 remainder 7. Okay. So 208 remainder 7. Let's see what else, if anybody else got any other answers. Okay. So you get the same thing there. Alright, anybody else want to chime in there? Please go ahead and do so before I go ahead and map this out. Okay, so let's go ahead and excuse me, write in. All right, so if you do that on the calculator there. You got, again, 208 is correct. Okay, that thing is spot on. Alright, and again, showing off the work here, you got 2 times 23 is 46. Alright, and you subtract here, you get 1. Bring down the 9. Now, as you can see here, it goes in 0 times. Okay, so again, 19 does not go into 23 does not go into 19. So you get 0 times 23, which is 0. And then we have the 19 here. Bring down the 1. And then we have 8. 8 times 23 is going to be 184. And so indeed, as correctly stated, we indeed get a remainder of 7. So that is the correct answer, 208, remainder 7. Absolutely spot on. Very good. Oops, didn't mean to do that. Any questions about that? So you can see we just kind of methodically went down step by step. Even there, if there's a 0 in the middle, again, we still represent 0 there. So, you know, it doesn't change a thing with 0 in the middle. Yeah, absolutely, Alyssa. We can certainly do one more. Absolutely. Let's go ahead and do another one here. Just make sure you have your calculator with you, Alyssa, okay? I'm going to make up a couple numbers here this time, so that way it's a little more randomized. Let's do one that would be a little tougher if you try to do it with mental stuff. So let's do 163 on the outside and 342,568 here on the inside. So bigger numbers here. Okay, I agree, but let's go through this again one more time. So again, on the calculator, I want you to do 342,568 and divide that by 163. Now, like I said here, you're going to get some whole number with a decimal attached to it. In this case, if you do that, you get 2101 on the outside. You get 2101 point something something something, but we only care about the 2101 part. If I can write the 1 in properly, then I'll let you know. There we go. Alright. So, do you see where we got that part from there, Alyssa? Want to be sure that that makes it clear about where I got that part from. I just want to be sure that when we go through this step by step, it's going to be clear. That's all. Okay, cool. Now I'm just going to go through this step by step in terms of doing the actual division so I can see what my remainder is. So I'm going to take that 2, I'm going to multiply it by 163. Again, you can plug that in the calculator if you want. Again, just have to do a little bit of the calculations here. So we get 326 if we multiply by 2. Then of course, just like we've done before, we're going to subtract each time down. If we subtract 342 and 326, we get 16 here as a result. And we bring down the 5. Alright, with me here so far, I hope? I hope everybody's here with me here so far. Hopefully this is just, again, just like what we did last week. We're now just applying the same techniques again. But now we actually have just the numbers. Alright, cool. So it goes in one time. 1 times 163 is still 163. That part not changing. So this is where we get 2. Bring down the 6. So 163 does not go into 26, so we put 0 up here. So we have 0 times 163 is still 0. So here we get 26, and we bring down the 8. Alright, so we get 268. That goes in one time, get 163. And so finally, get our last result here, which is going to be 105. So our answer here, just with these random numbers, is going to be 2101, remainder 105. I hope that made sense now. So, are there questions about that? If there are, then please just point them out so we can kind of smooth out those wrinkles and stuff. Any questions at all about this example, or anything that's hopefully you're not lost on there? That's what I'm hoping for anyway. Nope, all good? Alright. Cool. Alright, that works. Hey, no problem. That's why, look, that's why you ask. You ask and you shall receive. No problem. Okay. Alrighty. Let's go ahead and take a look here at a couple more long division issues. Basically dividing by multiples of 10. If you divide by multiples of 10, all you need to do as the shortcut method here is to drop the number of zeros from the whole number. So let me show you here really fast. This concept here by itself is not so bad. So go ahead and show this off here. So in this case here, if you look at 505,000 divided by 1,000, so a small little trick you can do is, if you have the option, is that you can just eliminate zeros here. So you can cancel out this 0 with this 0, you can cancel out this 0 with this 0, and you can cancel out this 0 with that 0, and that leaves you with 505 over 1, or 505. So whatever's left, you just cancel out each respective 0 there, and there you go, you got it. It's actually pretty straightforward. I do want to put a note with this though, actually a rather important one. This doesn't work all the time. Okay, so this doesn't work all the time. And the reason why this doesn't work all the time is because if this top number didn't have zeros on the top here, so if these 3 zeros didn't exist, well then the problem is that you can't cancel out these 3 numbers here. So okay, so that's kind of like the issue there. The issue is, if this was like 505,000, like maybe this was like 1, 2, and 3, yeah, I can't cancel those out. That's definitely not how that works. So that's why I say it doesn't work all the time. Essentially, it must be zeros. All right. So yeah, it can't be any other number but zeros. So that's why I would just kind of want to point that out there in that particular case. If there is a 0 that you can cancel out, cool. then you're solid gold. If not, well, too bad, so sad. Let's look at the next one here. Let's look at another one here really quick. 2600 divided by 100. All right. Can anybody tell me here, really quick calculation, 2600 divided by 100, what would that be? So 2600 divided by 100. What's that going to be? All right. Very good. That's correct. Yeah, 26. That's correct. Good. Good, good, good. Right, so again, you're just eliminating the zeros there. All right, so you got 2600. I can just do this quick here. 2600 divided by 100, sorry. What am I doing? There you go, 100. So we just eliminate the zeros. We got 1 0, 1 0. Got 2 zeros up top, 2 zeros on the bottom. We can go ahead and swap those, eliminate those out. I'm left with 26 here. Spot on. Okay, so not so hard in doing that shortcut there with powers of 10. All right, with 10 or 100 or 1,000. Again, we have to have the number of zeros there. If we have a 0 up top, we have a 0 on the bottom. That's fine. Another way to think about it this way is, here's another way to kind of think about this. If you had like 100, let's say 1560 divided by 10, again, it's just that first 0 that would cancel out, and that's it, leaving you with 156. All right, so same deal kind of going on here. You could just chop off a 1 0, because that's all you got, and you're good to go. All right, so that's it is what it is there. It is just fine. Again, what it does make some of the long division a little bit shorter. So for example here, if you were to look at a problem like this, and let's go over this one here really quickly. I'm not going to spend too much time on this example, but I'll just kind of show this off here. So if you see here on this example, we have 3,400 on the outside, and we have 190,400 on the inside here. So we're doing 190,400 divided by 3,400. Well, if you want to make this problem shorter and easier to do, again, you can cancel out the zeros here. So you can cancel this 0 with that 0, cancel out that next 0 with that next 0. And so effectively what you can do is you can effectively rewrite the problem. You notice you have 34 left here on the outside. That's what you're dividing by. And since you got rid of 2 zeros here on the inside, since you got rid of these 2 zeros here on the inside, we're left with 1904. And now you can proceed to do the division from there, just like you normally would for pretty much any problem. So if I did that here really quick, I get 56, and then I just show off the answer here, how I get that, and it's not too terrible. So I think I get 170 here. Yeah. All right. Get 20, and then I bring down the 4, and then that's where we get 6. 6 times that is 204 exact. Okay. So so you can see here a nice little fast way of just kind of reducing the problem here. Sometimes in math, what will be helpful for you in the future is, can you reduce a problem into something that's easier for you to kind of understand? So I've talked about something in the past here, the past 2 weeks. It's just like, how do we change the problem into making it easier, or how, what's another method to kind of do it in a faster way? Like I said, there's many ways to approach the same answer. So this is certainly one way to approach the answer, is sometimes just reducing it down to something that's much more manageable for you, rather than dealing with 3400, I think everybody would agree 34 is a heck of a lot easier to go ahead and use. Alright, so really that doesn't require too much effort, as much effort I should say, for 34 as it does for 3400. Alright, so can we avoid, if we can avoid it, then we're going to try and avoid it and make it easier. Sometimes we can, and then sometimes we can't, because that's how math works. So, but in this case, we totally could, so we should be good to go. All right. Yeah, that's the same thing we did last time. All right, any questions about that? Again, if you have a question, type the question out or type no in the chat if you'd like me to move on. Nope. Okay. For some reason it's very dry in my place today. All right. Okay. All right. So, oh, you're froze for a little? Again, hit F5 if it froze, okay? So, I know my stream's running okay now. Like I said, I figured out the connectivity issues, um, so again, so if your stream freezes, you can hit F5 to refresh. That should be fine. You're more than welcome to rewatch it, that's fine, Yvonne. There's just one example there, so. So just remember, just refresh your like browser page or whatever, and yeah, F5. That'll refresh your browser page, and then stream should come back up. I don't know how much I did this weekend. Holy moly, I was just like doing everything I can this weekend, just trying to get this stream and everything to go through just fine, Made a lot of adjustments. Are there any other questions before we move forward? No. All right. Okay, so let's move forward here. All right. So let's do the next section here, and this section here. Stacy's like, yeah. Okay. All right. Okay. So the next thing that we're going to do here is we're going to do section 1.7, and 1.7 by itself is not going to take us too long to do. Okay, so this is talking about rounding whole numbers, and we're just going to talk about how to do that here very quickly. It isn't very hard if you do a very simple approach, and you'll see exactly how things work out. Okay, so let's go ahead and met this out here. I need to bring this up. So rounding whole numbers. So let's talk about the key. The key here is to underline, basically, I guess we should say underline and circle. Now I'll need to describe what underlining and actually, yeah, I should say circle and underline, but either way. We're gonna see exactly how this works out. So we're gonna just use a circle, we're gonna use an underline, and then we're gonna go ahead and see what we need to do about that, and see what how we can approach with rounding here. Now, what we need to do here is you just need to be on the lookout for two things. What do we need to circle, and what do we need to underline? All right. Circle basically the digit you want to round up or down. We want to round up. We want to possibly round up, I should say. All right. And then what we're going to do is underline the number to the right of what we circled. So it doesn't matter. Okay. And we'll talk about the big key here. All right. So here's how it's going to work. It's very, very easy. So what's the trick behind this? The trick is very simple. If the underlined number is between 5 and 9, so if it's like 5, 6, 7, 8, 9, then the circled number will go up 1. Okay, so go up by 1 digit. If the underlined number is between 0 and 4, then the circled number stays the same. Okay. Now there is kind of an exception to this, which we'll talk about here momentarily, but this is kind of like the basic idea of what we're going to be talking about here in this section for the next like 15 minutes. Is really not too bad. So if you take a look down here, it says do some examples here. Finding the place that which is a number to be rounded. It says round 83 to the nearest 10. So this is on page 51 here. So we're going to round 83 to the nearest 10. All right. Okay. So notice it says nearest 10. All right. Okay. So what I'm going to ask you now is very simple. Which of these two numbers here, the 8 or the 3, is the tens digit in this case? So of these two digits, the 8 or the 3, which one of these is the tens digit? Okay. Good. So the answer is 8. That's right. So since the 8 is in the tens digit, I'm going to circle that digit. So this is where the circle comes in. So I'm going to circle that digit. Okay? Because that's the tens digit, since I want to round to the nearest 10. Now we haven't rounded it just yet, but now I'm going to be adding one more thing here to the trick, but you'll see in just a second. Now the underlined number here is the number to the right is what we circled. So we circled the 8, so of course the other number here is 3. We're going to go ahead and underline the 3. Okay, now let's take a look at this here. That number there, 3, is between 0 and 4. If this was 0 or 4, this would also be included in this part. Okay, so we're going to keep this 8 the same. Alright, so this 8, if we're rounding here to the nearest 10, is going to be remaining the same. The 3 here, this is the other part here, and this is remember to change all numbers, including the underline, all numbers to the right. Actually, hang on. Let me try and say this. Remember to change the underline number and all numbers to the right of the underline number to zeros. Okay, so we're going to just change this to a 0, and there we go. We got it. The answer is here 80. All right. So this is kind of like a big note here as part of the process. All right. So let's look at the, all right, so let's look at the next one here, and let's see what we're working with here. So we got 54,702, and we have to round to the nearest thousand. Okay. All right, so really quick here, what number is the thousands? What number here would represent the thousands digit according to our example? Okay. 4. That's right. 4 is correct. So we're going to circle the 4, just like so, okay, because that's the thousandths digit. And we're going to underline the 7, since that is the number directly to the right of the circled number. Now, let's answer this question here. Do we round up, or does the 4 stay the same, or do we move that 1 up to 5? That's the question. So do we round up to 5, or do we keep it the same? This stays the same, move up to 5, round up to 5. Okay, so we got alright, so I got 3 to 2, got 3 to 3. It's kind of a 50-50, stays the same. Okay, let's look at this carefully here, okay? So, I did, yeah, I did. No, Yvonne, you're right. I did mean if we wanted to change that 4 to a 5. That's right. No, you're right. So let's take a look here. Oh, okay. So notice here we take the underlying number here. Yeah, okay. I see. That maybe I asked that wrong, and that's my fault. That's on me. That's on me. Remember, we only want to look at 2 things, okay? We only want to look at 2 things. We only want to look at the circled number and the underlined number. All of the numbers are not relevant until we actually change that number over, if we need to. So we're not going to factor in this first 5 here. We're not going to factor in the 0 or the 2. That's why I just want to look at what's circled and what's underlined. That's why I want to just kind of make this process significantly easier. Be like, all right, I only need to look at 2 numbers, and those are the only 2 numbers that I care about. So it'll go up, right? So the answer is indeed, you see that 7 here is between 5 and 9. So the circled number here, so I guess let me be a little more clear about this. So the circled number will go up 1. Okay. And okay. And I guess I'll put stays the same. So that's for between 0 and 4. Circle number stays the same. 5 and 9. 5 to 9. Circle number will go up 9. Alright. So this is going to go up 1. So we're going to change that 4 is going to change over to a 5. And now we're going to put in the rest of these numbers here. Now we'll change over due to this note. This is now going to change all to zeros here, just like so. Any questions about that so far? Okay, let's go ahead and do another one then. Alright. Alright. So I'm going to do another one here. And yeah, I'm going to need more space than this. So alright, so I'm going to pick a number of my choosing here. Alright, let's pick 9963 to the nearest why did the 4 round up if it's between 0 and 4? Because remember, you're looking at the underlined number. Okay, so do understand here. If the underlined number, so remember, so read this carefully here. If the underlined number is between 5 and 9, the circled number will go up 1. So the underlined number here is 7. So because the underlined number here is 7, that's the number to the right of whether to determine we're going to round up or down. That's why this 4 went up to a 5. And then we changed all the numbers starting from the underlined number, change those all to zeros. So that's why we do, that's why we're actually looking at, that's why we kind of separate the two. What I circle is what I see, what I'm going to try and round or stay the same. Goes up 1 or it stays the same. The underlined number is the number that I'm testing with. So that's how I know that 4 is going to go up in this case. I'm not actually looking at the 4 for the test, it's actually the 7 next to it is what I'm looking at the test. So if you read this trick here carefully, that is the key difference there. We're looking at the underlined number as our test, and then seeing if that circled number needs to go up 1 or stay the same. Okay, and we only got 5 more minutes, but I do want to do this last example here because it does highlight something very important. So I do want to at least talk about this here. So, oh, yeah, no problem. So let's go with the nearest 100. All right, so let's go with the nearest 100 here. All right. Yeah. All right. Oh no, that's okay, Yvonne. No problem. I just want to show off something that's important here, nonetheless. So I want to do the nearest hundred. So what digit is the hundreds digit? What number's in the hundreds digit? Okay, 9. Which 9? The first 9 or the second 9? Okay, that's correct. So we're going to circle that number there, and we're going to underline the number to the right of that 9. Okay. Okay. So let's take a good look here. Okay. So the second 9, correct. So let's answer this question here. When I change this number over, is this going to go up by 1, or is this going to stay the same? Let's answer that first. Is that going to go up by 1, or is it going to stay the same? What number do we have here? All right, again, read it carefully here. Now we're guessing, right? No guessing. Take a look at the trick here. Is the underlying number between 5 and 9? The answer is yes. Remember, the underlying number is the test. Is that underlying number between 5 and 9? Yes, it is. So, if it's between 5 and 9, that circled number is going to go up 1. Okay, that's right. Now let's talk about that, Yvonne, because you're correct about that too. All right, so it is going to go up. All right, so exactly as stated, you guys are exactly spot on. But see, let's see what happens here though. The problem is that this 9 turns into 10, right? Technically that would turn into 10, and that's kind of awkward to work with. Okay, so there is a little exception here, so that I do want to point out here. Actually, I'll put that down here. So the exception here in this case is if a 9 rounds up, okay, change it to 0 and add 1 to the next column over. Okay. Yeah. So if a 9 rounds up, change it to a 0 and add 1 to the next column over. I guess the next column over being to the left. So I guess I need to be a little more specific than that. Keep repeating if necessary for adding 1 to the next column. So sometimes you may need to repeat this. This is definitely one of those cases, which is why I want to point this out here. So this changes to a 0. This 2 also changes to a 0. This also changes to 0. Again, this changes to a 0 because we rounded up. Anything from the underline over will automatically change to a 0 from what we had from before for this note here. Okay. And, oops, I'm sorry, didn't mean to do that. And this 9 here, we're going to add 1 to this guy. 9 plus 1 is 10. So we're actually going to have 10,000 here to be our number. So even though it technically said to the nearest 100, which is true, we still are forced to put in 10,000 here as our answer because of the way we round here in this case. Okay. And again, you may need to do this multiple times to keep adding by 1 if you get 9 plus 1 is 10 plus 1 is 10 plus 1 is 10. You may need to repeat that several times. I mean, it could be literally any number with a bunch of 9s in the front. That's possible. All right, but you know, you'll eventually stop somewhere and then you'll finally have your answer there. So all right, are there any questions about this? No? My questions. Well, yes. My math lab just has my math lab has like the questions on the handout here. So the questions on the handout here are going to be different than the ones on my math lab. My math lab is just like computer generated practice numbers. Okay, so that's it's to be expected that the stuff on my math lab is going to be different than that of the handout. Yes, but it is the same concept, and that's the idea here. So your problems are going to look a little bit different there. Yeah, so don't worry, don't worry there, Jonathan. That's purely by design. My math lab has questions that are pretty similar to what you see here on the handout, but they're not, they're not going to be exactly the same there. My math lab is a separate, online component. Do you have any more questions, Jonathan, or anybody else? Does anybody else have any more questions? I just want to be sure that that's clear there. And I will be doing something about the scheduling stuff because yeah, you guys shouldn't be seeing quizzes to appear. I can see why because I got a lot of emails. I'm like, what's going on here? I don't understand. I don't remember assigning quizzes on the syllabus or anything like that. This was like really weird. So um, yeah, I wasn't sure what was going on there, but I'll make that change there. So I do apologize about that. All right, if there are no more questions, we're going to do the last half of section 1.7 next time, which is just adding, subtracting, multiplying, dividing with estimations. It really doesn't take too much time, so that's kind of like the latter half. And then we're going to get into section 1.8, and if we do have time here, section 1.10 as well. We are not doing section 1.9. 1.9 is not going to be done here. It's going to be 1.8 and then 1.10. So that'll be, so the latter half of 1.7, we'll do 1.8 for next time, which is exponents, order operations, and whatnot, and then 1.10 here, which I believe is applications. So if we get to that. So that will take care of what I want to do today. We actually got really far here today, so really, really happy with the progress here today. Like I said here, just really quick, once we do finish up section 110, then I will be announcing that first test and then posting that on my math lab once I do. Okay. I'll be describing more about that test once I make that announcement. So, all right. So that'll take care of today, everybody. I want to thank you all very much for coming out here once again on a nice Tuesday. Well, hopefully it's a nice Tuesday. Thank you, Yvonne. You have yourself a great day. All right. For those of you who are in my 11 o'clock class, please stick around. I will be back in about 10 minutes, okay, or maybe less than that. All right. For those of you who want to stick around for once again another lecture, you can for my 11 o'clock. But if you're not, then I wish you all a good day, and I will see you later. This will be on YouTube in 24 hours. All right. Take care, everybody, and we'll see you. I'll see you guys on stream in less than 10 minutes. All right. Bye.